Hey, what's up, everybody? Joe here. Hey, I just decided to put out part three here of our ICND1 blueprint analysis series. So we're going to cover real quickly here the IP addressing section three. If you haven't been watching, we've been covering in detail the blueprint for the Cisco ICND1 exam. So we've already done part one and part two. We're doing one section at a time. So we're up here to section three on IPv4 and IPv6 addressing. This should be fairly quick, relatively quick. There's not a lot of particular topics in this section, and they're mostly pretty straightforward. So let's jump in here. We've got IP addressing for IPv4 and IPv6. So let's see, we've got describe the operation and necessity of using private and public IP addresses for IPv4. So it seems pretty straightforward. What I would say there, you're probably looking at things like IP address classes. You're probably looking at things like understanding why we have private IP addresses in the first place, what the private IP address ranges are. If you're not sure what those are, look up RFC 1918. So those are going to be things like your 10.0.0.0/8 network, 172.16.0.0/12, and 192.168.0.0/16. Those are your private ranges. You're probably going to want to know all the different IP address classes and which IPs correspond to which class. So for example, like a class A would be anything from 1 through 127. Class B is 128 through 191, etc., etc. So that's pretty straightforward. Next, we've got identify appropriate IPv6 addressing scheme to satisfy addressing requirements in a LAN-WAN environment. So that one is a little bit more subtle and a little bit more loaded of a task. So of course, to understand any kind of addressing scheme, you need to first understand IPv6 fundamentals and the addressing structure. So there is actually a lot involved with that particular task. You're first going to need to understand IPv6 in general, how the addresses are made up, how the network ID and the host ID portion is made up, and then you're going to probably want to understand some of the more common options for IPv6 addressing. So for example, most situations you're going to have the first 64 bits identifying the network and the last 64 bits identifying the host. But you could come across some other scenarios as well. Like, for example, maybe a /48, where you've got the first 48 bits is for the network, the next 16 bits might be for the subnet ID, and then the last 64 bits for the host. Various different ways that we can sort of subnet out IPv6 to meet different requirements. So I guess I would be prepared for if they give you some sort of a scenario or a diagram or a question, say, hey, we've been given this particular IPv6 address space from our service provider, and here's the requirements. How would you carve it up? Okay. Moving on here to 3.3, this is the real doozy loaded question. It looks very subtle, but there's a lot to this. So identify the appropriate IPv4 addressing scheme using VLSM, so that's variable length subnet masking, and summarization to satisfy addressing requirements in a LAN-WAN environment. So this one is huge. This is one of those that I would say it should be highlighted in a huge red or yellow highlighter pen, right? Because there's a lot to this question that's a bit subtle. Basically what this is saying is you need to be a master of subnetting. I know it doesn't look that clear, but when you break these things down, IPv4 addressing scheme, variable length subnet masking, and summarization, what that's telling you is you need to basically be a master of subnetting. Probably the number one reason people do not pass the ICND1 exam is subnetting, okay? Because, and I can understand why, because this really doesn't come right out and tell you that, but trust me, you need to know subnetting, and you need to be able to do it accurately, and you need to be able to do it quickly, okay? Now, it's very, very good to start with learning the fundamentals and how all the binary math works and how the technicalities of this stuff work. But at the end of the day, when you go sit the exam, you're going to want to know how to do it very, very quickly, almost to the point where you can really do it in your head. Okay, there's lots of resources out there, books, videos, training and stuff that can teach you how to do that, but you want to make sure that you do know how. So when I talk about subnetting, this is going to be anything from you are given an IP address and a mask, and you need to find the network ID, or what you might hear called the subnet ID. You might need to find what's the first valid IP address, what's the last valid IP address, what's the broadcast address, what's the next subnet. These are all types of questions that you could have. VLSM part, you could be given a diagram and a topology and be asked to assign different subnets to different segments of the network based on some requirements. So that's a long-winded way to say you better be a master of subnetting or you probably will not pass the exam. Moving on here, 3.4, describe requirements for running IPv6 in conjunction with IPv4, and they say dual stack. So basically this is saying you need to understand what that means. Dual stack is simply where we are running IPv4 and we're running IPv6 at the same time on the same equipment. So we're actually running sort of two infrastructures at once on the same equipment so that we can seamlessly transition from an all IPv4 network into an IPv6 network. So that's our dual stack. And then 3.5, describe IPv6 addresses. This is pretty cut and dry. It's telling you when you read into IPv6, you'll find out there are many, many different kinds of addresses. It's not quite as cut and dry as IPv4. So we've got global unicast, and we've got multicast, link local, unique local, etc., etc. And there's also various different IPv6 address ranges that correlate to these first four. Okay? So I would know the definitions of those, and I would know which IPv6 ranges fit within each category there. And then, of course, understand what EUI64 is, which is basically a way that your IPv6 interface can assign itself its own IP address, which is somewhat based on the MAC address of the host. There is an algorithm for that. You want to make sure you understand the step-by-step there. And IPv6 auto configuration on an interface. So that one, like I say, pretty straightforward. To recap here, I would say the major one, again, is subnetting. And that's kind of subtly pointed out here by telling you that you need to know VLSM and summarization to satisfy address requirements. And the rest of the stuff is basically just general knowledge of IPv4 and IPv6. You will notice that they've added quite a bit more IPv6 on in recent incarnations of the exam. But that's about it here for section 3. I'm going to finish up here before I have to get on my treadmill. I really don't want to run tonight, so I was kind of doing this video to procrastinate, but I got to get out there and keep myself healthy. So thanks everybody for watching. Again, if you guys want to shoot out some questions or comments, if you're struggling on any part of the blueprint, or let me know what you guys are studying so that I can help you guys out with some more videos, blogs, articles, and things of that nature. So leave me a comment. Let me know what's going on in your world with ICND1 study. Go ahead and subscribe to the channel if you're enjoying these. And you know what? I'd love to hear some comments on if you guys are enjoying these the analysis here, the blueprint, and if I should keep on going through. So let me know. Subscribe to the channel. Check out the blog at AstorinoNetworks.com or follow me on Twitter at JAstorino. Thanks for watching, everybody, and have a great night.